Good day. Today's video will focus on creating and utilizing external DLLs in Unreal Engine 5 via plugins. Before we begin, let me introduce myself. My name is Siddhant, and I'm an Unreal Engine trainer and a developer. I have been working with Unreal Engine, creating games and interactive experiences since the last 10 plus years at least. Now let's look at the learning objectives for today's video. Firstly, we'll learn how to use external DLLs with Unreal Engine plugins. Now, while I'll be creating a custom DLL, the techniques I show you in today's video will apply equally well to either custom DLLs that you create or DLLs that you either compile from external open source libraries or that you download from other sources. One requirement, however, is that DLL be written using C++. And next, we'll also look at how to translate custom data types that may be exposed via DLLs and use data from those inside Unreal Engine. Because data types that are exposed via DLLs may not be completely compatible, may not be directly compatible with data types that are utilized by Unreal Engine. So we will explore how to convert those data types. Let's look at some prerequisites next. Now, this is going to be a fairly advanced video. So experience with C++ and how to create DLLs in Visual Studio is necessary. Further, having experience with C++ and plugins in Unreal Engine is also necessary. And lastly, understanding Unreal's build system will be required. So what are we going to really build today? So we'll end up building a small plane that has a noise pattern applied to it, and that looks like this. So it will have this sort of pattern applied to it at runtime, and we are using a mesh, using a plain mesh that is built at runtime using library functions, external library functions, and the wave pattern or the noise pattern is applied using another library function that is defined in an external library. So we'll be building all of this today, and I'll be showing you two methods of calling those functions. Two methods of calling those DLL functions inside Unreal Engine. Now, before I can start working on the plugin, I need to have a custom DLL that I can use in my Unreal Engine plugin. And for that, I will first need to head over to Visual Studio 2022. Start by creating a new dynamic link library project. Click on Next, and in here, I'll name that new library as Mesh Library. I'll keep the location the same. I'll make sure I have place, solution, and project in the same directory, and I'll select Create. The DLL project is ready to go. Now there are certain ready-made files that are present here. I will delete all of them since I don't really need them. And I will go ahead and include the mesh library files that I already have. Now, one thing I do want to mention is that the source code I have is ready-made. I will just be using it as is over here, and I'll just explain it after including it. Now I'm going to go ahead and just import the files. Right click, select add, select existing item, and I'm going to add the mesh library header, and I'll do the same for the source file or the implementation file. And just to make sure everything's working fine, I'm going to right click, select rebuild, and yeah, there we go. It's working fine and the project is good to go. I'm just going to check quickly if the DLL is also available. So this is a project, and if I head over to the debug folder, you'll see I have the DLL and the library file. I'll explain the importance of the library file later. It will be required for linking the code when we use the DLL in Unreal Engine. Now let me explain the code. So between lines 3 and 7, there's this code block which decides whether the functions that are within this particular class will be exported or imported. Functions are exported when the DLL is built, and they are imported when the DLL is used. Below that, between lines 9 and 14, there are definitions for custom data types, such as vector3, vector2, and color RGBA. And lastly, we have the functions themselves, wave noise, and generate plane mesh. Now, the important thing here is that the definition that you see here is going to change depending on whether the DLL is being exported or it is imported. And one more thing, in the generate plane mesh function, you'll see I'm using pointers. So these are actually arrays that are modified internally, and these arrays need to be provided by Unreal Engine. Now let's jump over to the implementation file just to quickly see what that looks like. So at the top, I have the include files. Below that, there's wave noise, which generates a wave pattern using square root and sine functions. And then we have the generate plane mesh, which takes in vertices, size, and other arrays, which are these pointers. It will populate the vertices, the normals, the UVs, and the colors, and the triangles, and it will output those. And at runtime, then we'll have a mesh that has noise applied to it. Coming back to the header file for a moment, one thing I forgot to mention was about the extern C block. Now, extern C is important because this helps prevent name mangling, which is a C++ technique employed by the compiler to transform names of functions, variables, and other symbols into unique values. So we want to avoid that because it ends up adding some additional information to the name of the function. Now with this done, we are essentially done with our library. I'm going to now start working on the Unreal project. I'm now starting with the Unreal project. So I'm going to start by creating a new C++ project. I'm going to name this as plugin test, and I'm going to select create. Now this is going to take some time. So the project is now ready to go. So now let me bring up Unreal Engine. Let me head over to plugins and select add. I'm going to go with a blank template since we will be setting everything up from scratch. There is also a third-party library template available right here. I won't be using this since the purpose of this video is to show you how to create these and use them from a blank template. But in case you want to speed up the process of creating a third-party library, then this would be a pretty good option. Now then, let me select the blank template. Let me name my plugin Mesh Library Plugin. And I'll leave the author and description blank. It's totally fine. I'll select Create Plugin. And this might take some time. All right. So that will open up Visual Studio. I'm not using that, so I'm just going to end up closing it. I want to check Rider. So I'll need to check plugins. So Mesh Library plugin is already present, and I have everything I need under here. All right, so with the plugin now built and no errors showing up, we can move ahead. So now I'm going to start by placing the custom DLL into the plugin. That will be the first step. For that to work, I will head over to the binaries folder inside the plugin. So inside the plugin that I just created, I'm going to open up the binaries folder. Now where it says Windows 64, I'm going to right click and I'm going to create a new folder. I'll name this as third party and in here I will right click and create another folder which I will name as Win64. And in this folder I'll copy the DLL that was compiled from Visual Studio and place it in here. Now, the DLL is one part of it, one part of the plugin solution. Now, this is where we can have two different methods of working with the DLL. In case you don't have a library file or a .lib file, like in this case, you can work with the DLL, but the linking method will be slightly different. Whereas if you have a library file, then the method of linking will be different. So I'm going to go with the first approach in which we have the lib file, and I'll just move it inside the binaries folder. Inside the binaries third party Windows 64 folder. And one thing I want to do here, so I want to right click, select folder, and I'm going to name this as Mesh Library. And I'll move my Windows 64 folder inside here. So a final, actually it should be, yeah. So the final directory structure should be binaries, third party, mesh library, Windows 64, and then I have both the binaries and the library file in here. Now, this structure is a little important because in case you have multiple DLLs, then you can arrange them in the same subdirectory, in the same third-party subdirectory under here. Okay, now this is done. Next thing is I'm gonna head over to the plugin test project and we'll start making changes inside here. So I'm gonna head over to the build.cs file and now I'm going to head all the way to the bottom of this file I want to make sure I am inside the constructor, however. So over here. Now in the plugins build file, I'm going to add a few statements which will control how the library files and the DLL files are managed whenever the project is built. Now, the first thing we want is to ensure that we are on the Windows platform. So if target.platform is equal to Unreal target platform.windows 64. Next. Now, since I'm going with a method that requires a library file, I will use the public additional libraries variable, and I'll add the paths of the library file in here. Now, which library file? It's just this one. So it's this library file that we added before. Now, the entire idea of using the library file is that you're able to link the functions during compilation. And this will be helpful later on when we are calling the functions. Without the library file, uh, you will not be able to compile the plugin. There is an alternative method I'll be showing you later on that lets you compile without a library file. So I'm going to add the path in here now. So this path needs to match the path that we've had over here. So binaries, third-party, mesh library, Windows 64. Right? And after this, now, whenever we are calling a DLL, sometimes you might want to delay the loading of the DLL and not have it load immediately at the beginning. So for that, there is another variable called as public delay load DLLs. And I will just add the name of the library, of the DLL in here. So that's going to be mesh library.dll. Now we don't need the full path for this. Add, I forgot to add the add function. And lastly, if you want to package this DLL with the exe that is generated during project packing, the other variable that I'll need to use is runtime dependencies dot add, and this will require the paths to the DLL. So I'm going to copy this, and I'll just change the file extension to read DLL, and that should be everything that we need. So now with this done, we have the build file ready for using. Now the last thing I need here is the header file for the DLL in the public folder, right? So I'm going to search for that in the from the Visual Studio project. So this is my Visual Studio project. I have the mesh library header file right here, and I'll copy paste it inside the public folder of my plugins folder of my plugin. Sorry. All right, and that's it for now. Now, after this, I will rebuild or regenerate project files because I added a new file, and I'll change the build.cs project, sorry, the build.cs file of the plugin. So let me head over to the U project file. Now, from Rider, I can actually directly use the refresh solution option. But if you're not using Rider, you'll have to right click on the U project file from Explorer and regenerate project files. So that should be everything we need over here. And with this now, I will run a quick build to check if everything is building correctly. All right, so we're good to go. Now that we've successfully updated the build.cs file and included the header file for the mesh library, we can now begin work on actually loading the DLL from application code. Now, you can load the DLL from pretty much anywhere you want, but since it's inside a plugin, I generally would suggest loading it from the startup module function of the plugin. So I'm going to head in over here, and there's a few things I need to set up over here. So inside the header file, I'm going to have a handle to the library. So void star mesh library handle. This will be the handle that we will utilize whenever we want to reference this DLL. After this, I will now head over to my implementation file. Inside here, I want to first get the base directory of the plugin. So the base directory of the mesh library plugin. The way to do that is as follows. .get dot find plugin. So I want to find the base directory of the mesh library plugin. Right, so this will give me the base directory of the mesh library plugin. Now, after that, I will combine that with the full path. Oh, sorry, I'll combine that with the path of the DLL. Get the base directory. And then I want to get the path to the DLL. Which I'll take from here and just paste it in over here. So binaries third-party mesh library Windows 64 and mesh library.dll. And finally, we will actually load the DLL after this. So I'm going to use the mesh library handle is equal to f platform process get DLL handle mesh library handle, sorry, mesh library DLL path. And if the path is correct, this should load the DLL inside this handle. And then we can use it by checking if the mesh library handle is not a null pointer. If it is, then I'm just going to output a message. Pass in the namespace library error followed by the message. Failed load mesh library. I That should be everything that we need. I'm just trying to figure out why this is giving me an error. All right. And since I'm using the find plugin function, which should be from the projects, I will need to head over to the build.cs file for the plugins and just make sure I have projects added here, or I'll run into linker errors. Right, there we go. And I will actually just change this to use in here. I think that should be fine. And I'm just going to now go ahead and compile this just to ensure everything is correct. All right, that's good. So the library and the code have compiled properly. Now, one more thing we need to add is whenever the engine quits, we want to free the DLL handle. So I'm going to head down to shutdown module and I'm going to add f platform process free DLL handle, and I'm going to use the mesh library handle, and then I'll make the mesh library handle a null pointer. All right, so the plugin and project compiled properly. Now let's quickly run this. And I want to check if mesh library handle gets populated with a pointer value. And there we go, we have an address. Yep, so we have an address, and that means that the library loaded successfully. Amazing. So we are now done with whatever we needed to do to set up opening the library, linking the library. So now let's start actually working on using the library's functions within the project. So I'm going to close the project, and I'm going to include two new active files inside the plugin test folder. Now these are also ready-made project files. I'll just explain the code briefly. So I'm just going to drag and drop them into the plugin test project. I'll copy them, right? So in here, you'll notice we have errors with these custom data types. And one thing that we need to do here is inside plugin test, the plugin test build file, I need to add references or dependency module names for the plugin, which is mesh library plugin. Actually, it needs to be a string. And for procedural mesh component as well. So we'll be creating a runtime mesh, and I need procedural mesh component for that. So with these two, I'm now going to head back to deformable plane.h, and at the top here, I will now include a link to the mesh library.h file that was defined inside the Visual Studio project file. Now this is an important thing. So whenever you work with a DLL file, always ensure you have access to the header file firstly, and you have access to the DLL. And optionally, you also may need to have access to the library file. Now I'm going to head back to deformable plane. I'm going to include that plugin file. So that's going to be mesh library.h. And now you'll see that these no longer throw an error. So what's happening here? So I have this function that initializes data arrays. This simply initializes arrays as follows. The proc mesh variable is nothing but a procedural mesh component which I use to generate a mesh at runtime. I have arrays of inbuilt Unreal data types for vertices, triangles, normals, UVs, colors, and tangents. These get their data from these arrays, which are in turn populated via the plane generation method from the DLL. And you'll notice we're using custom data types over here. We are not using Unreal's inbuilt data types. Generally, it's not a good idea to mix data types between Unreal and external data types, even though they may look similar. Alignment issues and other issues could cause data to not be read correctly or not be written correctly, or they may just not be accepted at times. Then I have X vertices, Y vertices, and cell size. And lastly, this generate plane and apply noise function. So generate plane does all the plane generation work, and apply noise applies a runtime noise using the wave pattern, the wave noise that the DLL contains. Now let's jump over to the implementation file. So in the implementation file, I start by creating a procedural mesh component, and I set it as the root component of this actor. Then init data arrays simply initializes both the Unreal data type arrays and the non-Unreal data type arrays. Then generate plane simply generates the plane using the generate plane mesh function. You'll notice over here, I am passing Unreal arrays, passing memory locations of these arrays to the function, which is populating them in place. So I can then utilize them later on. And this is how I am converting from non-UV data type to UV data type. So this whole for loop handles that for the vertices, for the normals, for the UVs, and for the colors. And then I repeat that same data translation process for the triangles that we have here. And finally, I pass the vertices, triangles, normals, UVs, colors, and tangents to the create mesh section function inside the procedural mesh. And that creates the plane for us. Next, there is the apply noise function. This is using different values over here. We iterate over each vertex and just compute some additional properties. I then use the wave noise function that is declared in my library, and I get a noise value, which I then apply to the z coordinate of my vertices array. And you can, of course, pass these parameters. I'm just passing 1, 1, 1 over here right now because I got, at least during testing, I got good results, but you could pass any number in here. All right. So now with this, I'm going to go ahead and build. Yeah, before that, I will just make sure I refresh the project or I regenerate project files. All right, so that's done. And now let's give it a quick test run. Right, so it compiled properly. All right, now I'm going to head over and create a new level, just be a basic level. I'm going to save this to a new folder, which I'll name as maps. Right click. Oh, I would actually save this level. So save this to map, m underscore test, save that. And now I have my deformable plane class, which I will just drag and drop over here. You'll see I have my library plugin over here. And now if I hit play, there we go. We have a mesh that is now updating in real time using DLL functions. All right. Amazing. So this works well. Now let's talk about an alternative scenario where we don't have the library file available with us. By that, what I mean is, what happens if this library file is not available? What if we only have the DLL? So how do we run functions from the DLL when the library file is not available? I'll show you how that works next, and I'll make changes inside the existing project to demonstrate that. So I closed the Unreal project, and now I'm going to actually start moving some of the code around. So this handle, everything that we had inside the plugin, I'll now move it to the project file directly, to the uh, project module rather. So I'll start with the handle. I'll move that to the header file for the plane itself. Next, I'm going to head over to startup module, and I'll copy this code right over here, and I'll paste this inside the begin play event before generate play. Now, iPlugin Manager needs an include, and it will also need to be added to the build.cs file. All right, so that's good. Now we need to add some content in here, and we need to add function pointers in the header file. I'll get to that in some time. I also want to Now I also need to include this function in shutdown module. So I'm going to use the end play event. End play. And I'll paste everything in here. I'm just going to go ahead and remove it. because we know that this is working, and just to save on some time. The rest of the code remains sort of the same. The only thing that will change is this call and this call. Now, since I'm using function pointers, I also want to do one more thing. I'm going to remove this definition. I'm going to remove these function signatures, and I'll just keep the signatures that we have here, the vector3, vector2, and color RGBA. I'll need those. Okay. Now that we are done adjusting the class, I'm going to start adding the function pointers. Now the function pointers look like this, right? And you'll notice that these are type def. So you add the type def, you pass in the return type, the name of the pointer, and the parameter types after that. And then you declare a variable of that type. And I'm doing the same thing for generating plain mesh. And now going back to the code over here, I'm just going to replace those previous function calls by these ones. And there's a little problem over here. So I need to pass in 3 more float values, like so, and this should fix the issue. There you go. Now this is the way to do it. Now this is the way to call library functions in the scenario where you don't have a library file. Now, one more thing I also want to do here is I'm just going to comment out this mesh library.lib definition because we deleted the library earlier. I'll now go back to my project file. All right. And from here now, I am going to compile. Okay. So it compiled. And we have a problem. So let me see what happened. So I figured out the problem. I had accidentally deleted the define and undefined statements from the mesh library plugin implementation file, and I just ended up adding them again. So I added this and I added these two lines as well, which I had accidentally deleted. That is why the plugin did not load previously. And also another important thing that I did not finish was what to do inside once the library has loaded. So since we're using function pointers, we also need to assign those pointers. Right now, we are just declaring them, not really assigning them. Now to assign the pointers, we will need to follow the following setup. And I'm just going to copy paste this again it's already, since I already have it from my test project. All right, so what we're doing here is we are finding the name of the function in the library. We are getting its address and then we are assigning that to the pointer. And we are repeating the same thing for generate plane mesh. Now with this, we can directly call these functions without needing to link them prior. So now if I compile, with these fixes, once I now compile, everything built correctly. And if everything is set up correctly, we should have the exact same behavior. But now we are no longer required to use a library file and link the plugin at compilation. So let me head over to mtest and let me hit play. And you'll notice everything works just like before. Now, this pretty much completes the two methods of utilizing third-party libraries within Unreal Engine. So the first one is using libraries and linking the DLL, sorry, linking the library during the build process itself. And the second method that we saw was using function pointers when the library file is not available. Now, if you were to package this project, you'd also notice that the plugin will be packaged alongside other files in the package. And thus your third-party DLL will also uh, get copied within the package of any project where the plugin is utilized. And so with this, we finish with our session. Thank you.